Hi, welcome back. My name's Joel Duff. Today I'm going to talk about the Chixculub impact crater. That's that 66 million year old hole in the ground below the Yucatan Peninsula that has been blamed for the demise of the dinosaurs, right? And there was a paper published yesterday in Scientific Reports, which I found really fascinating. It follows up on a previous paper by the same authors 2 years prior, in which they revealed that they have found a location in South Dakota that is sort of, it's kind of the smoking gun evidence of the tremendous impact that this particular asteroid had on the Earth. And by that, I mean that they found evidence of sort of the tsunami and the raining down of debris that would have happened some 3,000 miles away from the impact center. And that is all preserved in the rock record. And I want to show that to you in a few minutes. So I want to look at the original paper from 2019, and I'm going to talk about some of the evidence for the effects of this particular impact across all of North America as evidenced at this site in South Dakota. And then we'll take a look at the more recent paper, which is detailing what they think is evidence of the time of year that the impact took place, which has some really interesting implications, which we'll get to down the road. Now, I've also titled this talk A Young Earth Mystery, and that's because I'm going to tie this to young Earth creationism. And we're going to take a brief look at how young Earth creationists have responded or could respond to this this evidence of an impact that was so long ago, but in their particular worldview, right, the young Earth worldview, this would only been about 4,350 years ago. So, did such a massive, um, explosive event actually occur 4,050 years ago or not? And what kind of evidence would they expect to find in the geological column of such an event occurring? And furthermore, does the evidence that we see and that I'm going to show you, can that at all be fit into the geological column of the young Earth creationist? So with that, let's get cracking on the Chixculub impact crater evidence. But first, just a little bit more about the Chixculub impact site. It's been dated by various radiometric means to 66 million years ago, and it represents the boundary between the Cretaceous period and what's called the Paleogene period. And it's a very distinct boundary because there's changes in the uh, evidence from the rocks of change in climate at that particular period. And there's a very distinct, I'm going to show it to you in just a second, a very distinct line found in some parts of the world in the geological column that is at this very moment in time that's been dated in multiple different sites on different continents. But the actual crater itself, or the impact site, is on the Yucatan Peninsula in Mexico, thought to have been created by about a 10-kilometer diameter comet striking the Earth, resulting in a disruption to the entire planet's climate, but was especially severe in, of course, Central America, but also in North America. All right, so as I was just saying, the impacts were very severe on the region. This article from PNAS from 2014 details some of those impact effects. And I'm showing this particular figure because I am going to we're going to be looking farther away than this point. But here's the impact crater here, and then all these green spots are impact triggered tsunamites. All right, tsunamites are basically the remains or evidence that a tsunami happened, right? You know, a large tsunami will move a lot of material around and break off trees and deposit things in places. These are all deposits in the geological column that have been identified as being at the very same time, all right, dated to the same date as the crater itself, and have the appearance, right? They have all the characteristics you would expect to find of a massive tsunami that dragged material far inland from what was the shallow sea at the time. And it, and so this is a wonderful piece of a set of evidence that has been found by scientists working on the Chixculub crater for many years. supporting the idea of the massive devastation that occurred in the about the 1,000-mile radius around the Chicxulub crater itself. And so you can imagine the extreme damage in this particular region. But we're actually going to go look all the way up here, all right, in Montana, or I'm sorry, South Dakota. Um, and there we're going to find a location that also experienced the physical effects of this particular impact. And that illustrates even more so how this affected all of North America. Right, I'm just going to show this one picture of one location, and I believe this is in Montana as well. Picture by Kirk Johnson from the Denver Museum of Natural Science, of Nature and Science. And in this shows the boundary right here between the Cretaceous below, and of course the Cretaceous is the end of the age of the dinosaurs. Remember, you got your three ages that sort of encapsulate the age of the reptiles. And then that comes very abruptly to an end in the geological column all around the Earth. And then above that is the Paleogene era or period above that. And then in this case, there's this sort of whitish line with this black stuff above it, which is sort of this burnt carbon material that's laid down on top. And then what's most famous about this particular area right here, this particular boundary between these two things, is a spike in the amount of iridium, which is a rare earth element, thought to have been incorporated, thought to have been part of the comet. And then when the comet struck the Earth and melted and completely vaporized, that iridium eventually fell out of the sky and then collected in various places. Now, not everywhere in the world you're going to see this line because many places were disrupted by various events afterwards, right? But if you had a large lake and material fell into that lake and then fell to the bottom of the lake, it would form a very distinct line, and that's what we see in many places in Montana, North Dakota, and then again in other places in North America, and then even on other continents, there's a discernible point at which this iridium layer is found. Okay, so that's the basics of the Chicxulub crater impact and what can be seen around the Earth America. But let's talk just briefly about young Earth creationism. So a quick introduction, right? Young Earth creationism, also known variously as literal day creationism, or creation science, is a movement dedicated to providing scientific support for a particular literal reading of the biblical book of Genesis. So in Genesis 1, when it talks about the days of creation, taking that to be literal 24-hour days, and therefore marking back the chronology of the origins of the earth all the way back to just about 6,000 years ago. And if the world is only 6,000 years and didn't include any death, then when we look in the fossil record, we see tremendous evidence of death, right? In young Earth creations, except that interpretation of the fossil record that those things that are fossils now were formerly living things. And if they were alive and then they died, well, what did they die from, right? They must have died after Adam's corruption, after the sixth day of creation, bringing in their interpretation death to all the other different kinds of creatures on the earth, not just to man himself. And and because therefore anything that has died must be younger than 6,000 years. So how are you going to squeeze all those fossils into all the world's rocks within 6,000 years? They look to the account in Genesis of Noah's flood. Read that as being a worldwide or global catastrophe in which Noah was preserved on the ark. And here I am standing in front of the Ark Encounter, which is Ken Ham's replica of his vision of what Noah's Ark looked like, and hopefully what he thinks is the approximate size. And so I've toured this. This picture was taken just I think 2 weeks after it opened. I took a trip down to Kentucky to see it. Looks more like this right now. I was actually there just 3 weeks ago and took this picture of the current Ark Encounter exhibit as it stands today. All right, but so critically, and this is going to be important for now my comparison when we start going through these two papers that I'm going to give you some highlights from. Um, if that flood is responsible for most of the rock or most of the sediment and fossil bearing rocks found on Earth, then somewhere in those rocks, right? Because it must be the Chixculub crater, which is found in the geological column down the Yucatan Peninsula. So then the site in North Dakota that contains this evidence of the effects of the massive meteorite impact must also be contained in that geological column somewhere, and must be have fit into just the past 4,350 years ago, which is when they say that that Noah's flood happened, and it was responsible for most of the flood record or the geological column. And here I'm showing you briefly, and I've talked at length about this in other videos if you look on my channel. But there are sort of two prevailing views among different creationist apologetics ministries. One of them answers in Genesis, which places all of the what they call the flood rocks, what happened during Noah's flood, into a region of the Paleozoic and Mesozoic, which includes the Cretaceous, and ends at 66 million years, or what is conventionally dated at 66 million years. That would be this very point we're going to talk about here. And they would say everything above that was some kind of post-flood catastrophe. So within the last 4,300 years, all of this material is laid down in the geological column by ice ages and other events like continents moving around and mashing into each other even after the flood happened. Now, contrasted to that is Timothy Clary, a geologist at the Institute for Creation Research, and he proposes that Noah's flood is responsible for all the geological column except the most recent period, which conventionally is dated 2.6 million years to present, but for him would be, again, 4,350 years to present. Answers in Gen says this is 4,350 years to present. So they have very much contrasting views of what rocks are part of the flood and which ones aren't part of the flood. Nonetheless, both of them have to explain where do you find the Chicxulub impact effects, right? Where do you find that in the flood? Was it right at the very end of the flood? And what kind of predictions would you make from that for young Earth creationists? What would you expect to see? And for the Institute for Creation Research and Timothy Clary, he would say, hey, this Chicxulub crater impact thing must have happened like right during the flood year when the world was covered with water. What effects would you expect from that? And do we see those particular things as evidence? The facts of the geological column that I'm going to show you in a few minutes, right? I'm going to show you some pictures of like, here's what we actually see. What is our best hypothesis for explaining the observations that we make? Okay, let's get to it. Let's get to the papers. All right, the first one is from 2019 by DePalma and a bunch of colleagues. The Proceedings of the National Academy of Science, so PNAS, a very prestigious journal, peer-reviewed journal. A seismically induced onshore surge deposit at the Cretaceous Paleogene boundary in North Dakota. And in this paper, he details a particular location that was discovered a few years before this. And of course, this work took several years to sort of get together, in which they found a very chaotic assemblage of fossils, of things that are kind of out of place and groups of things that you would normally find together, and mixtures of different kinds of sized sediments, in which were sandwiched between sort of what you could consider sort of normal deposits above them. So you had some deposits of what looks to be riverine deposits and sandstone deposits, and above it, you had some other deposits that are kind of more standard deposits from that region. And so there's just this weird amalgam of stuff. And when they started to look into that, and they had dated that, they knew that they were around the 66 million time period. And then when they got down to really more precisely dating, they found out the iridium layer, which is sort of that marker, right, for the very top of the Cretaceous period, is found at the very, very top of this mangled mess of stuff. And what they came to realize is this is a huge tsunami deposit, where you had a massive wave come in that brought material from what they had already determined was probably a shallow sea nearby up a river valley and then deposited on the side of the riverbanks in this giant mess, right? And then after that, the river probably carved out an area, but left this area untouched, and eventually more sediments were laid on top of that and was preserved. And so we get to see that today. And so they propose in this article that we are witnessing like the very event itself, like something that would have happened within 2 hours after this cosmic impact. All of this stuff you're seeing was formed, all right, by the direct effects of the impact getting to this portion of North America. All right, we're 3,000 miles away, but they're saying that the impact itself would have created a massive earthquake that has different phases in the way the earthquake propagates through the earth, reaching this area, and also a shock wave. And so there's actually physics calculations that have been done by many other people, not just this group, to determine how fast these things would propagate across the earth and when you would expect to find them arriving in different places. So they already had some predictions by other scientists before them of, if you were living in this particular location and this thing hit over here, what would you feel? The earth shaking, you would have an impact coming against you, you would have stuff raining down from the sky. Is like you could ask the question like, which one would kill you first, right? What would be what would be the first thing you would notice, and what would be the first thing that would be seriously worry you, right? And it turns out, even though you're a whole 3,000 miles away, most of these impacts all came within a fairly short span of time. All right, within 15 minutes, you're already feeling things, and then by the time 2 hours is over, everything's basically done. All right, and everything's settling out. And after 2 hours, you had the very light rain of the dust of the iridium that's falling and sort of settling on top of all the debris that's left. That's the image that is portrayed in this particular paper. Now I want to show you some of the things that happen there. I probably should have had this figure up so you could be looking at it while I was talking. So this is a figure from DePalma's paper, and right here we have this the iridium layer right up here at the top, and this is the boundary layer right here between this region right in here is the boundary between the Cretaceous below and the Paleogene above. Yeah, see right here the Paleogene. This right here, all of this, about 150 centimeters, so about a meter and a half of material, is the layer of stuff they found on a hillside in North Dakota. And in that layer, they found, and these are, they found plant materials, they found ammonites, they found various teeth from various placoderms and sharks. They found paddlefish, sturgeons, and so this is quite a collection of both marine brackish, semi-marine organisms. Or aquatic organisms, and then land-bearing organisms. They also found some they report that there's turtles, and they also talk about the fact that there are dinosaurs preserved in this, or remnants of dinosaurs preserved in here, but they have yet to publish that. I think that's kind of a teaser for the third paper. I think they're saving the dinosaur thing for last, because that'll be a big story, because no dinosaur has ever been found in the very, very top layer, right at the impact, right in the impact layer. And so that would be like, hey, there's an actual dinosaur that was killed, by the asteroid itself. Um, Whereas the vast majority of dinosaurs were not killed by this asteroid. We talk, the popular press talks about, oh, asteroid killed off the dinosaurs. Well, whatever dinosaurs might have been left at the end of the Cretaceous. And there's many questions about how many dinosaurs actually even survived, to the end of the Cretaceous. T-Rex might have been around, a few other dinosaurs might have been around, but most of the evidence suggests that a lot of them had gone extinct well before this particular period. So it's more appropriate to say that the asteroid impact was maybe the last straw, in terms of killing off what was already a dying lineage or multiple lineages of dinosaurs. You have to remember the dinosaur age is really thick and a long period of time. And most of the dinosaurs you're familiar with didn't live right at the very end of that. At least their fossils aren't found at the very end of that age. They're found like in the middle or like, in the Jurassic, right? And lots of dinosaurs existed in the Jurassic that never existed in the Cretaceous, according to the fossil record. But I digress. Let's get back to the point. Let's get back to our story here. All of this material is laid down. Now I'm going to show you these little spherals, and these are impact spherals or impact grain-sized material. And this is thought to come directly from the impact itself. Material thrown up into the sky at an extremely fast velocity, right, high velocity, and making its way all the way from the Yucatan Peninsula and then raining down as basically little blitz of molten glass that have already cooled by that time. So they're hard glass, but they're little particles of glass, spheres. And they're falling all over as this water is sloshing back and forth in this river valley and laying down these sediments very, very quickly. And so these sphericals kind of gets sorted out in there. And so they see those. We'll get to more of those. At the very bottom is a very coarse layer of the very heavy, larger particles. So actually like rocks, right? So like think of it as like gravel at the bottom of a river is kind of what's found at the bottom of this jumbled up region. And then below that there is a very fine sandstone, all right? And that sandstone is very even, kind of very evenly distributed with not a lot of other stuff in it, right? In other words, the fossils that are found right above it aren't found below that. And by the way, none of these fossils here, right? These fossils aren't found in the layers above, right? So they just have this section here of this group of fossils. All right, so now in this picture here, this is actually from the supplemental material from DePalma in 2019. So if you ever look that paper up, you really have to get the supplemental material. It's a huge, long file, but it has lots of great images in it. And in that, they have a cross section of this region that they're looking at. And what they're showing, and this is what's pertinent to the young Earth creationist mystery portion of the story, is that this event deposit, they're calling it, all right, this gray and this black area, actually mostly the black really, is laid down, and it's not horizontal. It's actually kind of running up the side, all right, or running at an angle. Whereas if you go down in the deposit, if you were to just drill a hole down through the deposit and get a core, you'd find that there are many, many horizontal layers of sediment. Actually, there's going to be, 2,000 feet of sediment below this that's all laid down. And in a flood model, all of that had to be laid down first before we even got to this point. But what I found really fascinating about this, and really an important detail when you're critiquing different hypotheses, namely the young Earth creationist hypothesis here, is that this bedrock goes up the side of the hill, all right, and it's in multiple different layers, which sort of represent different ecological conditions and climates and so forth. And we would say, for conventional geology, we say that would represent various periods of time of deposition. But then all of that horizontal distributed stuff you would expect should be going all the way across, but it isn't, because it appears that this rock, all these layers of rock, had been eroded. And in that area of erosion, you then had all this sand in place, along with some riverstone. And the idea is that, hey, if you go back to the Cretaceous period, right, if there were actually dinosaurs running around at this particular time and they were living on top of land that was made up of all these rocks and there was these formations, there's this river valley, and the river valley is carved down into this older rock. All right. And when it carved into that older rock, it left behind its own sediment. So on the side of the river side, so basically you have the river's down here somewhere, and this is sort of the floodplains. And in the floodplains, you just have all this sand, and that's all sitting in there. And so on top of that sand is this giant tsunami that then brought in all this stuff, pushed it up the river valley, up the sides onto onto the floodplain area, pushing it to higher and higher elevations, and then just left this giant mass of material, this 1.5 meters of material, although that's just in the place they looked at. It obviously gets thinner in some places and it's thicker in others. In other places, it's completely eroded and missing because what would have happened after the tsunami and everything settled down? Well, erosion takes place, so some of it gets eroded. Other places, more material erodes from the higher land up here and ends up getting deposited on top. So eventually you have more layers of rock on top of this. And then long after all of that gets eroded and it's eroded down, through here. And now we get to see the cross section, we get to see a side of a hill, right? And in the side of the hill, we can see these different rock layers. We can see the sandstone, and then we see, oh, what's this junk right here, sitting here in the side of this hill, which is just very different than everything around it. Oh, that's an amalgam of all kinds of stuff that represents stuff from like 20 miles downstream where it's in this estuary, right? And all that estuary stuff got pushed up, and then it got pushed beyond, and then it got settled down. Um, this was a catastrophic event, and you're seeing the evidence of that catastrophic event. Now, of course, the young Earth creationists would say, well, it's all a catastrophic event. But that's the thing. Not everything looks like a catastrophe, right? Most of the other layers of rock look like, standard sedimentary layers that could be laid down the bottom of lakes and other things, or at bottom of a shallow sea. Actually, some of these are marine sediments. And then you have the digging out of a river valley. Well, when did that happen? I mean, during a giant chaotic flood, how would you create rock and then erode the rock and then place it and erode it in what looks like to be a river valley, and then take that river valley and have all the sediment in it, and then add this other layer thing, and then just add more layers of sediment on top of that later as the river valley got filled up later in different environments that occurred after the Cretaceous. This is a complex geological location, and the thing about complex geological sites is it represents a complex history. A global flood that just mixed everything up and then boom, 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 laid everything down within the space of a couple weeks or a couple months wouldn't be expected to be this complex to tell a tale, to tell a history. Now, let's get to that history, because you might still be like, yeah, you can still wave your hands around like I am right now. And you can still like make stories that suggest that, oh, well, this could have happened really quick and water could have run off the land, and then during this flood year, and then maybe inside some channels and some soft mud, which got like, okay, there's all kinds of things you have to account for the specific data though, not for the general story, which I've got marked hashes all over here, right? It's a big giant mess. Let's look at what we found here. Okay, so first, again, in the supplemental material, this is all talked about in the paper, but the paper is very short because it's in PNAS, and they just throw all this interesting pictures and other additional information into the supplemental material. This is just one picture of the spherules that are extracted from this layer of jumbled up stuff. And these are not found in the rock above, and this is not found in the rock below. It's only found in this 1.5 meters. And what it is this is melted rock, all right, that are little tiny, these are very, very, very small, right? Millimeter, I mean, this is 875 micrometers, so this is only like 2 millimeters wide. Very, very, very small glass spherules. And what I like about some of these is like this one's like teardropped. And the idea is that impact melts the land, it spews up into space, right? Or all the way up into the high atmosphere very, very quickly. and begins to spread out in this giant hot blanket, and the shock wave pulls it out there, right? And then as it goes out and it reaches a cooler temperature, all the melted material cools and turns into these little spherules. But since they're flying through the air so fast, as they cool and harden, they turn into these elongated pieces of glass. Um, so especially the ones that are the teardrop form, like they're falling out of the sky, they're melted, and then they're hardening on the way down, and then they land, all right, in this material, right, that's being moved around by these tsunamis that have been caused by the impact as well. Now, the second paper we're going to look at, it actually describes like the timeline and all this, and it's like, only 10 minutes, I think it was 8 minutes, 10 minutes, and 13 minutes are the different massive earthquake portions of the earthquakes that would have happened. And that would have literally shaken the ground so much because it's like a 10 or 11 size, impact. I'm sorry, earthquake. And so just the movement of the ground moving so fast would have, disrupted the river and the oceans there, creating the beginning tsunamis. And then you had um, what do you call it? The shock wave. Okay, I knew there was a word for that. All right, the shock wave emanating out from there, coming just another 10 minutes later, right? And then that just pushing, right, this water and everything that's already kind of bubbling and frothing from being rocked around by these earthquakes, that shock wave then just starts to cram everything up there. And if you have a shallow sea nearby, that water gets into a huge wave. They're talking, well, down there in Chicxulub, they're talking about, a mile, couple miles high water. Here, probably, just like 100 meters or something like that, but still absolutely huge, right? And that's going pushed up this river valley, which is what's suggested in the geological. People done all the geology in that area, and so that's mixing your brackish salt water, mixing it and bringing up all the organisms that are found in there, and those organisms are being swept up the valley, churning up the rocks that are in there, mixing it all up with a bunch of mud, and then pushing it up the sides of the hills, and then it's moving back, and then it's moving back forward again and back. That's what happens in tsunamis. It's usually not just one time up and back. There's kind of a rebound effect. And so in the back and forth, you have stuff dragged over this area, deposited, stuff comes back, some stuff's deposited, stuff comes back, deposited, comes back, more stuff is deposited, and you actually get layers in a tsunami, a massive tsunami. You can end up with layers of material, and that's what we find in this particular site. It's not just one glob, it's actually multiple stacked layers of material that, as I'm going to show you, sometimes is moving one direction, sometimes it's deposited in the opposite direction. But the spherules themselves is amazing, incredible evidence of a massive impact, because they're going to be it's very difficult to form that kind of glass spherule. There's only a few conditions on Earth where that would happen, and you wouldn't expect to find, and there's nothing in this particular area that suggests there's a specific type of volcano that could have created that. And besides, these spherules are found in these deposits or just below the iridium layer all over the world. All right, so that's a very consistent nature. So I said that you have layers, and this is an interesting example of, in this case, these layers aren't very obvious, but they've identified unit 1 is the more coarse material, then you have unit 2, there's actually another unit above that. But this thing right here is a large log that is petrified in here, so it's preserved. This is actually the outline of it. And then all this stuff is a bunch of fish they have found. So there's lots of different fish that are preserved in this material. And this is an interesting example of like a polystrate tree, right? So this is a couple meter long one. And so what they're saying is that you had this original material laid down by the first push, and sort of the heaviest material falls out there, and you ended up with this big heavy log which got pulled up and pulled up, slid up the side of this hill. and it's stuck inside the unit one and sort of sticking out. And then when the material sloshed back and then deposited all this material, it deposited the rest of it around the rest of the log. And the log goes like all the way right up to near the boundary layer, where the iridium layer is. And so that's an example of a polystrate tree, right? Because it's actually going through multiple layers of material. But in this case, it seems pretty obvious that all these layers are laid down literally within 2 hours of each other, right? So, and probably maybe within 15 minutes of each other. So you can get a large amount of material deposited in one location, and you can even get multiple layers of material laid down in one location within a very short time span. Okay, so another, and I'll say this is another piece of evidence that fits with all the other evidence. These are high resolution X-ray images of fossils of, I think this was sturgeons or some kind of fish. And these are the gill areas of the fish. And in the gill areas, they're full of these little bits of ejected spherules, or the glass bits of melted rock. And so these wouldn't be here if the fish were already dead and were simply deposited in the soil, all right, in the sediments. And so the idea here is that they think that these spherules actually arrived within, say, 15 to 20 minutes, which sounds really astounding, but apparently the physics works out on that in terms of how fast they could actually be transported there. So these glass bits are falling into this water. You have fish there that are, being dragged around. They're trying to live. They're still alive at this point, and they're sucking down, opening their gills and trying to get oxygen. Well, all this glass is basically filling up their gills and getting stuck inside their gills. And so this is evidence that the fish are basically in their last gasp, all right, are actually sucking down the glass sphericals from the explosion. So again, like this is the smoking gun evidence that, hey, this impact crater, this impact killed organisms, like as a direct result of the things that it caused. The other thing about the fish is that they're directional. So there's hundreds of different carcasses of various fish, and um, they're laid out in a particular direction, with most of them facing the same direction. All right, so that suggests a very strong flow of water in one direction. And then what's interesting is that in a layer above, there are other fish, and the fish are actually mostly facing the other direction. And that's also the idea that you would have had a tsunami moving up, right, the valley, then it's kind of moving back again, and then maybe being pushed back up again. And so you have multiple layers laid down, but with water direction in different ways. What I don't have is a picture of there's 7 or 8 other different things that they measured at this particular site. One of the other ones is that you can tell the direction of motion of the water and the deposition based on how the sand is being laid down, or how some of the sediments are being laid down. They will have a particular direction to them, and then the directions change 3 times in this just 1.5 meters of stuff. All right, so let's go with the second paper. I'm trying to whet your appetite for maybe looking at these papers. I think they're quite readable, even though they have a lot of jargon in them. They're just chock full of really interesting evidence. So this is the paper from yesterday: seasonal calibration of the end Cretaceous Chixculub impact event. Right, the thing that ended the Cretaceous period, because it changed the world so much that it's a clear demarcation of a point in time where the world wasn't the same after that. And we can see that in the geological column from all over the world. Just a couple things from here. Now, this paper it's the same authors, or most of the same authors, especially the first author who's directing this research. And what they were interested now is, like, can we fine tune this? Can we get even more detail about this site? And what they were interested in is, can we identify what time of year that the impact took place, right? Was it in the wintertime? Was it in the summer, spring, maybe fall? And what they decide is it's probably late spring into the summer, sorry, summer, basically summer, could be late spring, could be very early fall, but certainly summerish. And how do they know that? They present several different forms of evidence. One that's not in here, but I know is in the other paper, is the types of leaves that are preserved. So the types of plant material that's preserved. This is North America. It's thought that even in that particular time, there were winters in North America. And so you have the type of vegetation preserved at this site that would suggest that, no, this is during the summer, it's during the time, growing period of time. But I think more interesting data would be, so from sturgeons, um, they look at the oxygen isotopes in some of their in their, well, not in their bones, but in their scales. And so in the scales, oh, I'm sorry, this is in the bone. So in their bones, this says the distance from bone surface. So over here, 0 would be the very outer edge of the bone surface. And then down here we have so we have the thickness of the bone here. And if you measure very carefully in that bone, you'll find preserved in that bone the signatures of the oxygen isotopes. So oxygen has different isotopes, and depending on whether the sturgeon is living in freshwater or it's living in salt water, it picks up different oxygen isotopes and then incorporates that into the things it's making, which is bones. And since it's making bone over time, all right, during its growth over the whole year, sturgeons in this case, they're moving from the ocean and then they're spawning and having young in freshwater. And then during the winter time, they're moving back into the salt water, right? Like many different types of fish do today, like salmon and so forth, right? So these spikes are high salinity, and then the lower values here are low salinity, suggesting freshwater. Um, so they're living in freshwater. So the most recent bone formed we have has, let's just stick to the top chart here, has the lowest amount of a particular isotope, suggesting the animal is living in the freshwater at the time. If it's living in the freshwater at the time, well, that means it's probably in the summertime. When it's gone to freshwater, late spring, early summer, when it's gone into freshwater to spawn. So, what caught my eye about this too is that, this is really interesting evidence. Things you can learn from fossils are really amazing sometimes. They're quite precise. Just from this fossil looking at one bone, you can find, for one thing, evidence that these animals, which today can move from freshwater to saltwater, in the past were able to move from freshwater to saltwater. Um, and so this is a cyclical cycle, right? This is an annual cycle that you're visualizing as you look at this. And so we're just saying, yeah, we can see an annual cycle, and then we can look and we can say, well, this animal died, at this point, and when it died because of this catastrophe, what time of year was it? And then that's also backed up by the growth plates. And so if you look at how the bone grows, it grows in bursts, all right? It grows kind of like tree rings on a tree. There's sort of signatures for early spring when the growth rate is fastest, and then it kind of slows down through the rest of the year and kind of goes into stasis, and then it will grow again the next spring. So there's that kind of growth rate also in sturgeon bone, and so they can look at that and say, oh, this is winter, all right, and then we have summer and spring, and we have winter and autumn, and they go down here to say, well, the last bit of bone, all right, that's formed, is still in the stage of, we see spring and summer, and that's consistent with the oxygen isotope data. So I mentioned that. I also mentioned the plant material being probably summerish. And then there's also, in this case, there's insects. So there's mayflies. There are lots of mayflies that are preserved in there. And if you know what mayflies are, if you're from Ohio, you know what mayflies are, because they breed up there on Lake Erie, and by the hundreds of millions of them. And they drive people crazy, but it only happens for a couple weeks, right? The mayflies don't actually eat, and they're just the last stage. They're just there to reproduce and lay eggs. And so they're only going to be around for a couple weeks. And probably that's the way mayflies were back then too. Right? There's something like a mayfly, not the exact same species, but a mayfly type of thing. They also found some cocoons from mayflies in plant material, and but the actual bodies of the mayflies being there are really important, because that's the evidence that that's probably the summer as well. They're not going to be doing that in the wintertime. Again, what about this? So what we're doing is we're combining multiple different forms of evidence to form a pretty strong picture of this happening in North American summertime. The other thing they did was they looked at a bunch of different fossils of several different types of fish. And so if this had happened at the time when fish had just spawned, and but before anything had hatched, then we wouldn't have any young fish, right? This would just be adult fish that were here. But what they found is that there are some fairly young fish, but not like tiny little fish, right? And so they know sort of the general growth rate or how long it takes for fish to mature to get to certain sizes in different basic groups of fish. So they looked at those different groups of fish. They looked at the sizes of the fossils of the most juvenile ones that they could find. And they discovered that the age ranges were for different types of fish all fit the same profile in terms of like this is the size you'd expect them to be around this time of late spring and into the summer. And so all of these things come together to say, hey, this is a late spring, early summer event. Now, it's kind of like you might be like, well, who cares? When it happened. I mean, it happened and it was bad. Um, I'm interested in this from the perspective of, this young Earth creationist angle, right? Why would any young Earth creationist have a prediction as to what time of year this took place? Why would you expect to see these types of patterns, or how would you explain these types of patterns? I can't think of how to explain that, especially for Clary, who believes that this is like right in the middle of the flood. So right in the middle of flood, why would these sediments preserve juvenile fish that are all of a certain sort of age class? Whereas other parts of the fossil record have all different shapes and sizes of fish, right? Which suggests that it's capturing fish at all different types and times of the year in different parts of the fossil record. So I know if young Earth creationists want to say, well, what happened with the flood is all the organisms that were alive at the moment the flood began, that represents all the different fossils that are going to be there. Why would why would there be lots of if it happened at one time of the year, right? It was winter in North America, when the flood event began. Well, then we would only expect to find, basically in all the northern hemisphere, is we'd expect to find fish at certain life stages, right? We expect to find the plants at certain life stages. We expect to find insects at certain life stages, because that would represent what they were doing at that time. Now, they might come back and say, well, but different organisms are in different places of the world at different life stages, and they're all getting mixed up in the flood. Well, if you're going to say everything's just chaotically mixed up, then how did you sort out in the middle of a flood? How did you sort out and only end up with certain age classes just in this one layer of rock? Which others are saying, identifying as this happened at one moment in time. We're capturing a snapshot of 2 hours of time, right, in the history of the Earth. And if you're going to capture 2 hours of time, you're capturing 2 hours of that moment on Earth. What was happening at that moment on Earth? It happened at this particular time of year, and it's consistent with what you would expect to see in that community. And like I said, if you dig up and you dig down from this particular point into other layers of rock and look at the fossils that are there, you're not going to find the same pattern, right? Because those rocks are laid down at other snapshots in time that weren't necessarily this particular time of the year and with those particular types of organisms. I think that this should be, this type of evidence, it's when you dig down and you look at the details. All right, it's when you start looking at the details of the evidence the sphericals that are found here, the iridium layer that's found here, the size of the fish, the types of plants that are present, the way that the organisms are organized, the fact that this is in an incised river valley inside of other rock layers, right, which then is filled in later with additional material, is completely inconsistent with anything that a young Earth creationist can come up with. They talk in huge generalities about how the flood happened. It's when you get down to these types of like, okay, well, how did this happen? It kind of doesn't kind of fall apart. It completely falls apart. Um, yeah. So last, let's come back to the question of what do young Earth creationists actually think of the Chixculub crater? So Timothy Clary, who I've mentioned before from Institutes for Creation Research, who generally supports this idea that the flood is responsible for almost all the geological column. He wrote a paper for Answers Research Journal, which is a journal of a peer-reviewed journal from Answers in Genesis, um, entitled "Do the Data Support a Large Meteorite Impact at Chicxulub?" And his conclusion is, well, he doesn't think the data is quite as strong as generally believed. He admits that there are pieces of evidence that suggest some kind of meteorite impact. He says a case can also be made that there was no impact. He doesn't really make this case in this paper at all because he doesn't actually explain the data in other ways. Each individual data point, you can kind of throw out a possible exception, shocked quartz. That could happen under some super special condition that might have happened during the flood at some particular location. The problem is that all these pieces of data all come together in one place, and you have to all be explained by probably one event. You can't simply explain sphericals of like the tiny little microspheres of glass, shocked quartz, the types of fossils that are present, the fact that there are hundreds of different tsunami deposits in a circular area around the Chicxulub crater that are all dated to the same age. All those things can't be explained by different things when they all seem to point to the same cause. Um, but anyway, he spends, you know, a lot of, well, what do we got here? 17 pages of talking about how maybe this isn't, maybe this isn't, maybe this isn't, maybe this isn't. And at the end, he kind of admits, well, of course, there were probably some meteorites that struck the Earth during the flood. All right, but we need to critically assess this site, and before incorporating the flood models, we shouldn't just accept what other scientists say. Besides, what he's objecting to is he says that it killed the dinosaurs. Well, how could they have killed the dinosaurs? Because the dinosaurs were on the ark, they were preserved. And then the flood killed the dinosaurs, not a meteorite impact. So at the end, you kind of reading between the lines, kind of like, yeah, okay, well maybe there was, some large meteorite or comet, and it hit the Earth right at the time the world was flooded. But who cares? It wouldn't have made that big of a deal. But he doesn't address. No, this was 2017, so he couldn't have. But he doesn't address most of the types of evidence that people have brought forth for this meteorite impact. And certainly I haven't seen him respond to 2019, and of course he hasn't responded to yesterday's paper. But those are the papers that should be extremely challenging to his point of view. Oh, I just had this as a reminder. He has to find and place all that evidence somewhere in here, right during the middle of a year of this massive flood, which the whole world is covered with water. Somehow he's got to get this sorted material, different directions, only certain plant material there. The iridium layer has to somehow be laid down in that thin, very thin, precise layer inside of a chaotic global flood that's laying down hundreds of feet of sediment a day sometimes. Um, it's just not workable. And then Answers in Genesis, you might say, well, maybe they have a case. Maybe they're saying that was the end. Like the flood is kind of like over, things are receding, and then boom, the Earth gets hit by this giant meteorite or comet, and chaos ensues. But it's mostly on the other side of the world, not where the ark is. And then it causes a giant tsunami, and maybe these things happen. The problem with that is there's a bunch of different organisms that are alive, and there's obviously trees that were there, and there's all this stuff that wouldn't make the kind of collection that you see there. You still can't explain why um, you have the incised valley and you have the previous sediments there from the river sediments, um, and so forth, right? It's really not workable as well. Now, interestingly, Andrew Snelling, the resident geologist at Answers in Genesis, he wrote a short paper for Answers Magazine, Dinosaur Killer, Chixculub Asteroid Impact. And in that, and this is from January 1st, 2020, so several years later, this is actually after the evidence that I've just told you about, the first paper. And I know that he saw that particular paper. And he seems to be convinced that that is a smoking gun evidence of a catastrophic event that created that particular layer of material. Um, and so what does he say? He says, well, okay, how do we fit this into, this is actually at the bottom of the paper, the creation flood model perspective. Well, so he asks a good question. How then, whoops, how then do we reconcile all this with the biblical perspective on Earth history? That's a really good question. It's like he presents a bunch of evidence that, yeah, it's obviously something hit the Earth and created a calamity, and all these different geological effects resulted from it. There's no denying this Chicxulub impact occurred during the flood. Now, that's the opposite of what Timothy Clary is trying to say. He's trying to cast doubt on it. At the same time, Andrew Snelling is saying, you can't deny that this happened. Right? This is just one of many, many cases where these two different organizations are butting heads in terms of just like saying just opposite things about their interpretation of the physical evidence in front of them. They like to say, like, we all have the same evidence, we just interpret it differently. Well, usually what they mean is secular science interprets this way, we in biblical science interpret it this way, but it turns out they also interpret it completely differently as well. Um, and then, so how does he explain it then? Well, there's no denying it happened. And then it's just kind of like, well, just as God rained down fire and brimstone on Sodom and Gomorrah, he was fully capable of raining meteorites and asteroids down on Earth as part of the flood judgment. Okay, so maybe this is just all part of the judgment on man, that not only is he going to flood the Earth, but he's going to like boom, 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 pound it with these asteroids and meteorites at the same time to kind of like churn things up even more. Um, After all, he told Noah that he intended to destroy all flesh along with the earth. Somehow these organisms, so maybe, these organisms, especially if there's dinosaurs in these sediments, but there's a bunch of organisms that appear to have been alive when they were killed by this event. And don't forget, below this site, there's several thousand feet of geological column. All of that had to be laid down by a global flood. So what were these organisms doing while below them thousands of feet of sediment were being laid down in this chaotic flood? How did they manage to survive? Why would fish that, especially fish that live in fresh water and places with clearer water, how could they have survived the churning waters with all the mud in it? And then here you have this fish that has survived that entire time, and then it's killed by glass spheres that fall from the atmosphere. So I don't know. Maybe Andrew Snell is saying, hey, look, God needed to add these extra elements because some things were gonna did a good job of surviving for the first 100 days of the flood. They managed to eke it out, and now it's like we're just gonna lower the boom on them, like the final nail, hit them again. All right. He may have even used an asteroid impact to trigger the waters of the flood. Now, that's the suggestion some creation scientists had, that maybe an asteroid impact hit the Earth with such extreme force that it began the whole continental drift and continents breaking apart and all that. All right, and he admits, right? Many impact craters have been found at different levels in the rock record of the flood, along with some fossilized meteorites, this raining meteorites, and so forth. Yeah, there are other meteorite impacts. I mean, the Chicxulub crater is actually a buried crater. It's not really visible to you if you were to visit that area. It's been filled in since by, in his mind, post-flood events. But there are a lot of other craters that we now know about that are also covered up by lots of other sediment. And when we date those, they're dated to different ages. So secular, conventional geology would say like through Earth's history, we've had a number of these types of events. Chicxulub crater happens to just be the largest event that probably had the largest impact, but there are other things that probably impacted an entire continent to some great extent, but maybe didn't completely change the world. And he's acknowledging, yes, there are these other impact sites, and so these things could have been happening around Noah as he's floating around in his boat. All right, so the Chicxulub event. Evidence of a global catastrophe? Absolutely. Evidence of a global flood catastrophe? Definitely not. The two seem to be absolutely opposed to each other in terms of how how the Chicxulub impact event, how that shaped the land, very much fits a profile of water being dragged out of a saline environment up through fresh water, being laid out onto what was land, not part of some global flood where everything is already flooded and then you're just moving water around even more because of an impact. All right, so that's my overview of a paper just published yesterday. If you found that interesting, I'm sure I'll talk about other current papers and other things related to science and faith issues, and I do that in writing at thenaturalhistorian.com and here on my YouTube channel. Again, my name's Joel Duff, and thanks for listening.